we are given a 4 cross 4 matrix represented by T and 4 options associated this problem. We have to ask to determine the validity of 4 statements. First statement is saying there is a non-zero vector which is not in the image of T. Image of T, it means we have to check range of T. Option B, there is a non-zero vector which is not in kernel of T. So you can say kernel of T or null of T, null space of T. Option C, there is a non-zero vector which is not in the kernel of T. For this you will check null space of T. And D, 1 1 1 1 transpose. Transpose means this is a column vector, you can understand, plus kernel T represent the straight line. So if you call this vector, given vector as V plus kernel T represent the straight line. For this you have to check kernel of this transformation or matrix. Correspond to every matrix you can consider a transformation. So sometimes question can be easily you can understand. Now dimension of range space of T, null space of T. To find dimension you need reduced form of this matrix, and pivot element will tell you rank and nullity of this transformation. Apply elementary row operation to predict rank and nullity of this matrix. So I am writing final equivalent matrix. So 1 0 0 0, 1 2 minus 1 minus 1, 0 minus 1 1 1. It may be possible your matrix final equivalent matrix cannot be same, but row reduced echelon form is unique. Reduced echelon form is not unique, row reduced echelon form is unique. So it may be different from your side. So you can observe this is first pivot element, second pivot element, third row and fourth row are same or in proportion. So you can make one row as a 0 applying elementary row operation. So you can delete. So this is third pivot element. It means rank of T is 3 and nullity of T, nullity means number of free variable is 1. It means dimension of range T equals to 1 and dimension of kernel T, or you can say null T, is dimension of range set is 3 and dimension of null T is 1. Range of T, its dimension is not equals to 4. It means there is at least one vector which has no preimage. Suppose this is domain and codomain, and this is range set. So range set generated by 3 element, it means there is some vector which has no preimage. It means there is a non-zero vector which is not in the image of T. There is some non-zero vector. Option A is true. There is a non-zero vector which is in the kernel of T, because dimension of kernel T is 1. It means there is a non-zero vector. If it is dimension of null T equals to 0, then there is no non-zero vector. But dimension is 1, it means there is some non-zero vector which is in the kernel. Option B is true. There is a non-zero vector which is not in the kernel of T. Not in the kernel of T. So suppose this is a domain and this is kernel. So dimension of kernel is 1 and dimension of range set you can say this is codomain. So there is a non-zero vector which is outside the kernel, not in kernel. It means there are some vector outside the kernel. So this statement is also true because of range set has some dimension. Now this is affine space. Option D is affine space, or you can say coset. So is it representing a straight line or not? You need to check dimension of the kernel. So we already calculated or evaluated dimension of kernel T equals to 1 and 1 1 1, this vector we called u plus kernel T. How this set looks like? Suppose you are adding a single point to every vector of the kernel. It means you are just shifting kernel T by this vector. It means you are shifting space kernel T by vector u. So it means 0 of the kernel, because kernel T forms a subspace, it means 0 of this kernel you are also shifting by this vector. It means you are adding some quantity to each vector of T, then dimension of T is again 1. After shifting this kernel T by this vector, again dimension is 1. It means it is representing a straight line. If dimension equals to 2, then it is a plane. If dimension is 3, then 3D plane. If dimension is 0, then point. But we know that dimension of kernel T is 1, that means it is representing a straight line. So all 4 options are true.